Warm air at the equator rises and heads towards the poles. Let's look at the northern hemisphere. As the warm air moves north toward the pole, it bends east because of the Coriolis effect. By 30 degrees north latitude, it is moving more east than north and it's cooling. As it cools and loses its push to the north, some of it drifts back down. This creates a relatively high pressure zone at the surface right at the horse latitudes. On the ground, the high pressure that forms at the horse latitudes pushes air south toward the equator. This completes a cycle of airflow known as a Hadley Cell. A Hadley Cell is a band all the way around the planet between the equator and the horse latitudes. Now let's look at the pole. The high pressure on the ground, caused by the sinking cold air, forces air on the surface to move south toward the equator. Think of it like pouring a bucket of water out onto the ground. The water hits the surface and spreads out. Cold air at the pole does the same thing. It rushes to the ground and then spreads out. So at the horse latitudes, air sinks toward the ground and heads back toward the equator. Like the bucket of water, it hits the ground and spreads out in both directions. Air from the pole is moving south. These air masses meet halfway and collide, and air rushes up. The sudden uprush of air leaves a low pressure zone known as the subpolar low at a latitude of 60 degrees. This forms the Ferrel cell and the polar cell. Remember that these cells, plus the Hadley cell, are really bands circling the entire planet. These three cells are the basic ways of dividing up the planet into weather systems. Their boundaries are created by high pressures and low pressures.